Have you ever stopped to look closely at a spider's web? Perhaps on a cool morning, when it is hung with tiny jewels of dew. It looks so delicate, so fragile, that the slightest touch might break it. Yet, this delicate structure hides an incredible secret. A single thread of spider silk, though thinner than a human hair, is, for its weight, stronger than steel. It is a material so remarkable that it has captured the human imagination for centuries. It is one of nature's most elegant and surprising inventions, a true marvel of the living world that we are only just beginning to understand. This seemingly simple thread is far more than just a sticky trap for unsuspecting insects. It is a lifeline, a nursery, a home. The story of spider silk is not just about spiders. It is a story about engineering at a scale almost too small to comprehend. It challenges our very ideas of what makes something strong. It pushes scientists to think in new ways and inspires materials that could change our lives. Join us as we unravel how silk is made, how it stacks up against our best materials, and how it could shape the future. So, what exactly is this miracle material? Spider silk is a protein fiber. It starts its life not as a solid thread, but as a thick, liquid gel stored inside the spider's body. A concentrated soup of special proteins. Specialized glands hold this liquid potential, each tuned for a specific silk. To spin a thread, the spider uses spinnerets at the rear of its abdomen. As the liquid is squeezed through, a remarkable transformation occurs. Pulling and stretching aligns protein molecules precisely, and chemical tweaks remove water and adjust acidity to lock the fiber, all at ambient temperature. A single spider can produce up to 7 types of silk, each for a job. Tough frame, rigid spokes, stretchy glue-coated capture spiral, absorbing kinetic energy without breaking. Spiders can change diameter, strength, and stickiness on the fly, building complex, biodegradable structures from renewable resources, their food. The true wonder of spider silk lies in 2 seemingly contradictory properties: immense strength and incredible elasticity. Strength here means tensile strength, the force required to pull until it breaks. Dragline silk, a spider's lifeline, excels on this measure. Pound for pound, it can be about 5 times stronger than steel. A hose-thick cable could theoretically catch a passenger jet, but strength alone doesn't tell the whole story. Silk pairs strength with remarkable flexibility. Many plastics are flexible but weak. Steel is strong but rigid. Some silks stretch up to 4 times their length before breaking. That extensibility lets webs absorb high-speed impacts. Toughness is the ability to absorb energy and deform without fracturing. Strong but brittle versus not as strong but tough. Silk can absorb up to 3 times more energy than advanced fibers like Kevlar, and it is astonishingly lightweight. An Earth-circling strand could weigh less than a bar of soap. High strength, high toughness, low weight, a blueprint for next-gen materials. To appreciate spider silk, compare it with everyday materials. Steel is the backbone of our modern world. Skyscrapers, bridges, cars. Strong and affordable, but heavy and rigid. Spider silk is feather-light and exceptionally stretchy. Nylon revolutionized textiles, durable, light, fairly strong. Yet, against spider silk, nylon falls short in strength and toughness. Strongest silks outclass nylon and stretch far further before breaking. Steel has a crystalline metallic structure. Nylon is long polymer chains. Silk is a protein polymer with ordered crystals for strength and amorphous regions for stretch. Its hierarchical structure gives unique properties. Manufactured at room temperature, using water as a solvent, and powered by insects. Steel demands immense heat. Nylon needs harsh, petroleum-derived chemistry. The spider shows a powerful yet gentle pathway, high performance with a smaller footprint. You can't yet buy a pure spider silk shirt, but the journey has begun. The biggest hurdle has always been supply. Spiders are territorial and cannibalistic, hard to farm at scale. So scientists farm the silk proteins instead. Through genetic engineering, microbes and other hosts produce silk proteins. Bacteria, yeast, even modified silkworms and goats act as biofactories. Medicine leads early applications. Silk is protein-based and generally biocompatible. Think ultra-fine sutures for eye repair and nerve surgery. Strong, low inflammation. Silk scaffolds help grow skin, ligaments, even bone, then safely dissolve. In textiles, lab-grown silk proteins blended with fibers yield lightweight, durable, more sustainable gear. These prototypes prove the concept. Now the challenge is perfecting spinning, to match a spider's flawless fiber. Each success, no matter how small, brings us closer to unlocking the full potential of this ancient yet futuristic material. Looking beyond today, possibilities are limited only by our imagination. Imagine vests as light and flexible as shirts with superior protection, saving lives without weighing people down. Tougher helmets and vehicle armor that resist impacts. Aerospace and automotive silk-reinforced composites. Every pound saved means fuel savings and reduced emissions. Silk's strength to weight could build lighter, equally strong parts. Even space tethers and solar sails become feasible. Silk could host soft, wearable electronics that move with the body. Comfortable biosensors for real-time health feedback. And when the job is done, silk biodegrades, reducing plastic and e-waste. Challenges remain: high cost, industrial scale-up, and matching natural silk's consistency. With innovation and investment, teams worldwide are spinning these dreams into reality. If you're enjoying this deep dive into nature's super material, tap like, share this with a curious friend, and subscribe for more mind-bending science. Tell us your favorite spider fact in the comments. The story of spider silk is more than a tale of a remarkable material. It is a profound lesson about elegant design. For millions of years, the spider has engineered with simple, sustainable tools, protein and water, at room temperature. In stark contrast, our industries often rely on brute force, immense heat, and toxic chemicals. This is biomimicry, the idea that nature is a mentor, not just a resource. Study webs, lotus leaves, seashells, and find efficient, sustainable, planet-friendly solutions. Each organism is a living library of time-tested solutions. Protecting biodiversity preserves knowledge and future innovations. Next time you see a web, see a masterpiece of natural engineering and a source of hope. What other natural wonders should we explore? Comment below, like, share, and subscribe for more. Thanks for watching. Stay curious and stay connected to the genius of nature.